Okay, so here's my Genius Hour project. So Dylan Nelson's Genius Hour project. What I wanted to do is I wanted to create a high efficiency, or the goal is to create some kind of a high efficiency wind turbine, at least compared to what I've created in the past. The reason why I wanted to do this is I've just been interested in it. I used to teach, before I taught my engineering class, I taught an earth science class, and we went over renewable energy, and my students would often ask me, how do wind turbines create power? And that all often led to a discussion that I wasn't quite sure the answer to, and so I just started experimenting and trying to build wind turbines to better answer my students' questions. So just going over a few things with the turbine. Everything's hand built, so made out of a majority of it's made out of wood. I first started by building my turbine blades, and I tried to, as best as I could, mimic typical wind turbine blades that people see. Although in the future I would probably do it just a little bit different than what you see here. After doing research, I found that wind turbine blades, they do kind of work similar to fan blades, but they mostly actually work like an airplane wing. So if you'll actually look, on the back of the blades, I made the blades completely flat, okay, and you can see that here. But then the front of the blade here is rounded, and then at the top, it's rounded at the top, and then it goes, just curves back down, right? And it creates, that creates lift, so when the air comes over it, it creates lift outward this way. So I did that. I attached it to a 3/8 inch dowel, which is running through 2 ball bearings, and I did this to reduce friction. The past ones I hadn't ran it through ball bearings, and it was either like wire on cardboard or wood on wood. It created quite a bit of friction, which made it had to have a lot more force coming through here to spin the rod. And in my past ones, I actually hadn't geared it, and I did some research and found out that a lot of wind turbine blades, all of them, just about, are geared. And so it wasn't much, but I purchased a couple of gears, a big one and a little one, so that way when my blade spun, it was spinning the bigger gear, which has 30 teeth, which spun a smaller gear, which had 12 teeth, which means every time the big gear spins once, it spins the small gear over twice. And then this gear is attached to another 3/8 inch dowel, once again run through 2 ball bearings to reduce friction, which connects to my generator up here. I have wind turbines aren't exactly like this, but this is the best that I could do with my situation. So inside here, this black thing is magnets. And what happened is I wrapped around my magnets, 4 ounces of 28 gauge, I believe it's 28 gauge magnet wire. There's a lot of wire in there. Anyway, and what happens is, because the magnets attract the electrons in the wire, the magnets spin, which induces current inside my coil. And then on this side, I have attached a light bulb to it that shows that if it's generating electricity or not. And when the bulb lights up, it's about a volt of electricity. And so what I'll go ahead and do is I'll go ahead and just spin it. With this camera, sometimes it has a hard time seeing the light, unfortunately. What we've got here, if I just go ahead and spin it fast enough, you can see that we generate electricity. Now my goal was to generate electricity, high efficiency electricity or whatnot, I live in Idaho, and there's a holy moly amount of wind in Idaho. Unfortunately, it's not high efficiency for a few reasons. One of the reasons is I believe that my blades, they're pretty fat here, close to here, but they get super duper skinny, so really all the wind that's catching them, that's helping it spin, is here. I should have kept them thicker going through. Another issue is with my lift. I created the shape of the blade so that it would turn when wind hit it, so that it would turn clockwise. But unfortunately, when I designed the lift, because the rounded parts on top, it's creating the lift out this way, which actually when the wind blows into it, it actually makes it want to go counterclockwise. So it has to take a holy moly amount of wind to counteract the counterclockwise lift, and so that made it a little bit less efficient as well. There's obviously human error, quite a bit of human error. This gear and this gear, right now they're perfect, but I was not able to get them perfectly aligned, and they're actually about 2 to 3 millimeters off, but just that 2 to 3 millimeters actually does create some friction in this gear, which does not allow it to spin perfectly. And anyway, so that would be some things that I would change on this. And I already gone over why it's important to me. So yeah, so the science and engineering, it's NGSS aligned. So it goes over asking questions, and it went through some SEPs and some CCCs, and the major science and engineering practices that I went through were asking questions and defining problems. So mostly defining problems because it was an engineering thing that I did. So I wanted to make it high efficiency. So I defined criteria and constraints, and some of my criteria were that I wanted ball bearings and gears. And some of my constraints were just because of, I don't have that much money, all I had to work with was wood, right? So that was some of the constraints I had, and I also had a time constraint. And also developing and using models. So this is obviously not a real hardcore wind turbine that you'd see on the side of the road, but it is a model of it. And I used mostly one cross-cutting concept, which is structure and function. I knew the function that I wanted, which was induced current. So I created the structure based off of the function that I wanted. And then as regards to assessment, there would be a couple of things that I would use for the assessment. One of the things that I would use for the assessment would be, I would like for, after it's created, obviously I'd give them some points for creating it and getting it finished by that point, by the deadline that is assigned. Another thing that I would do is I would have them, whether in a video or preferably a video, would be to have them identify and justify the science and engineering practices that they used. I would also, I like the idea of having them keep a time log, and I would like them to work at least a specific amount of time on their on Genius Hour projects if I was to do this in my classroom, which I really like the idea of it. But I would like to have part of the grade be the time log. So those are my thoughts. That's my project.